In this section, we'll be looking at problems number 42, 49, 54, 49 through 54, 27, and 29. Alright, so let's get started. So we start with our sinusoid problem of the day. Alright, and this one is a high tide question. Alright, now if you look back at your test and quizzes, and we've hit this problem quite a bit. Alright, at Ocean Tide Dock, the first low tide of the day occurs at midnight, which is alright. So let's just start this with breaking this up into the time of day. I'm gonna go two in here, two in here, two in here. Alright, that gives us all the hours in the day. Alright, that being 12, 6, 3, okay, 9. Alright. And 24 hours, time of day. Alright, and so let's look at the information given. Alright, so they tell us that at midnight, alright, we get the first low tide, alright, and that's a depth of 2 meters. Alright, and at 6:30 a.m. the first high tide happens. Alright, 6:30 a.m., which we need to change to a decimal value. We divide our minutes by 60, and so that becomes 6.5. Alright, and the depth is 8 meters at that point. Alright, midnight, which is the beginning of that day, is 0. Alright, so that's the same as 0. Alright, so we have two pieces of information. Let's give our y-axis here. Alright, that way we can go, well, we'll just put 8, 9. Alright, we're at 8 meters is the high, and the low is 2 meters. Alright, and this is depth. Alright, we want to label everything in meters. Alright. Alright, time and day and hours. Alright, and so we have it's not that straight, but it's a pretty good graph. Alright, we set everything up, then we plot some points that we know. We know that we have a low tide at 0 or midnight, and we have a high tide at 6.5. Alright, and that would be 8 meters. So 6.5, comma 8. Alright, now that distance, 0 to 6.5, is obviously 6.5, and that lets us get from low tide to high tide. Alright, now if this is sinusoidal, in which they tell us it is, alright, it'll take the same amount, same distance in the x direction to get back to the low tide. So we go 6.5 plus 6.5 gets us to 13, or 1 p.m. That'll get us back to 2 meters. Alright, so we're going to say 13, comma 2. Alright, if we go 6.5 more, that'll get us to 19.5. And that'll put us back up at the top, 19.5. Alright, comma 8. Alright, and the next time we have a low tide, it would be in a different day. Alright, so from here we should be able to come up with an equation. Alright, but let's finish sketching this. Alright. low tide, and we can just, this will give us that full credit on, just make sure it curves some, guys. All right, so we're gonna go with that. We labeled our high tides and low tides. All right, good to go. All right, next thing. So we sketched and labeled a graph showing the depth of the water as a function of the number of hours after midnight. All right, determine a trig function that models the graph. So here we go again. All right, we're going to start with A. All right, we're going to say that A, all right, is equal to your max height, depth, minus your min, divided by 2. So in this case it's 8 minus 2 over 2, which is 6 over 2, and that's equal to 3. All right, while we're at it, let's do D. All right, and D, our vertical shift is m plus, big M plus small m over 2. So that's going to be 8 plus 2 over 2. That's 10 over 2, and that's 5. All right, looking at the shift, the phase shift, all right, if we write a negative cosine, all right, we say negative cosine functions, we talk about the Drake song, all right, started at the bottom, all right, and if we use cosine, negative cosine equation, then we have no phase shift, all right, and that's okay. All right, so that means that we're going to say C is equal to 0 if we use negative cosine. Now, if we happen to use a positive cosine, all right, for our equation, which we're not going to do, then we would go over to the top and we would take that x value, which is C would be 6.5. All right, now remember we're going to do the one with the negative cosine. All right, and what's left? Well, we have our B value, all right, which is 2 pi over our period. All right, and remember we find our period is either the distance from high to high, or the distance from low to low, or distance mid through a mid. All right, and we have a good low to low here. So we go from 0 over to 13. All right, and so that's our period, all right, which is 13. So here we have 2 pi over 13. All right, now got everything we need, I think, so let's keep it going. So let's write the equation. All right, determine the trig function that models the graph. So we say the depth at some time t is equal to, now remember we want negative cosine because we're starting at the bottom. So negative, our A value is 3, cosine, 2 pi over 13, x, well x minus 0 or just x, all right, plus 5. All right, so we got our equation. All right, hopefully it's right. We're about to check it because we're going to be asked some questions, or that last question we need our calculator for. All right, so let's get it. All right, I'm going to second plus 7, 1. I'm going to clear this. All right, and we're going to start fresh. Negative 3 cosine, parentheses, 2 pi divided by 13. Close that. Open an x. All right, remember our C value is what it is. All right, plus, oops, we have to close something, I think. Close, plus 5. All right, so now that we have that, let's see if we can get the proper window. We go from 0 to 24. All right, we went by hours, 1. All right, and we're going to go 0 to 9 in the y direction. If you want to keep 10, that's fine. All right, we want to make sure we are in radians. All right, right now I'm in degrees, so we want to be, oops, I was in radians. All right, and so I'm going to try to graph this and see. Yep, goes down, goes up, and on the way down. All right, so it looks pretty good. All right, look like we know what we're doing. All right, so the next question says, suppose a ship requires at least 3 meters of water, depth in planning a dock after midnight. It's planning the dock after midnight. Determine the earliest possible time the ship can dock. All right, so we're looking at this graph, and so we want to go to 3 and go right over to 3. It's around what looks like about 2 something. I'm not sure. All right, but we do know that we want to find the intersection of 3 meters. So we go y, same thing we've been doing before, 3, and we put the horizontal line in the equation. All right, now to get the answer, we go second calc, intercept. All right, first curve, I always hit enter, and I scroll across the horizontal line. It just takes less time if you do it that way, more efficient. All right, we hit enter on second curve. The cursor's near there. We're going to not guess. We're going to hit enter, and it gives us our answer. And it tells us that the earliest is 1.74. All right, if you want to write more decimals, because we're going to have to work with this anyway, is the earliest time. And that's not really a time, all right? That's the decimal value, all right? In order to find the proper time, we got one more step to do for C, all right? And that's to take the decimal portion of your answer. We know it's at 1 hour and 0.74 of an hour, all right? So we need to take this 0.74 and multiply it by 60. All right, so we're going to go 0.740 0.74 times 60, and that'll tell us that this is 4.4 minutes of an hour. All right, so we're saying that this happens at 1:44 a.m. All right, number 49. It says a truck is traveling down a mountain. A sign says that the degree of incline is 7 degrees. After the truck has traveled 1 mile, 5,280 feet, how many feet in elevation has the truck fallen? All right, so let's say this is the ground, I guess, or somewhere along this hill. Let's draw this in. All right, this truck, this is it. All right, has gone down some hill. All right, and the truck has traveled 5,280 feet. All right, which is 1 mile. All right, so you can imagine some trucks starting here and going down this hill. All right, this hill is 7 degrees. All right, is the elevation. All right, I'm sorry, the degree of incline. All right, so you can imagine a truck going down a mile. All right, down this 7 degree incline. All right, after the truck is, how many feet in elevation has the truck fallen? So if the truck started this high and then it went down to here, all right, what we want to know is, hey, right triangle, all right, that distance. All right, now look at what you have. You have the hypotenuse, all right, you're looking for opposite, you know the angle, all right. So, hey, what are we dealing with? It sounds like we're dealing with sine x is equal to opposite over hypotenuse. All right, so we're going to say sine. We're going to say that sine 7 degrees is equal to x opposite over hypotenuse 5,280. All right, and then we're going to solve for x. Multiply both sides by 5,280. All right, and that's going to give you x is equal to, well, let's find out. 5280 sine 7, close it, make sure it's in, always check your mode, please. All right, make sure it's in degrees. All right, and the answer is 643, and they wanted what, 3 decimal places, so 470 feet. All right, that's that. All right, number 50. All right, a garage owner. The owner of a garage shown below plans to install a trim along the roof. The lengths required are in bold. How many feet of trim should be purchased? Your answer should be correct to 3 decimal places after the decimal point. All right, so I'm looking for this distance and this distance. All right, now those distances are the same. All right, if the angles are both 50 degrees, then the 2 lengths are the same. All right, so if I add 50 and 50, I get 100. All right, so let's redraw this so I can kind of mess it up a little bit. All right, so I got 50, 50, that's 100. That means that this angle is 80 degrees. All right, so I just want to do that right away. All right, just should make sense to you. All right, remember we're trying to get this length. All right, and you know this side is 20 feet. So we need to find one of these lengths, and we got to know that, hey, we're dealing with an isosceles triangle. So if I know one, I know the other. All right. So let's figure out what we're going to use in this case. All right. We have the angle, we have the side, and we're going to use law of not cosine, sine. All right, and so we're going to go, let's say we look for this one, even though they're the same, just choose one. All right, we're going to go sine 80 degrees over 20 is equal to sine 50 degrees over, let's just call it, for the sake, you know, what we always call it, x. All right. Now, if we do that in our calculator, all right, after we cross, let's cross first. 20 sine 50 degrees is equal to x sine 80 degrees. All right, we want to divide both sides by sine 80. All right, and that's going to give us x is equal to all of that. All right, and in this case, let's see what the answer is. 20 sine 50 degrees divided by sine 80. Make sure we are in degrees, and we are. Enter. All right, and so it tells me that that side is 15.557. All right, now that means that this is 15.557. All right, and this is also 15.557. All right, and so if I just multiply that by 2, it'll let me know how much trim I need. All right, And so I need, or the garage owner needs 31.114 linear feet. All right, is what it what should say, but we're just going to say feet. All right. All right. Number 51, an airplane needs to take a detour around a group of thunderstorms as shown in the figure below. How much farther does the plane have to travel due to the detour? All right, your answer should be correct to 3 decimal places. All right, so what they're asking us to do, all right, it usually would follow this 50-mile path. All right, instead there's storms here, so it had to go around. All right, straight up, 34 degrees, and then I had to go back down to get to its spot, destination. All right, so what we want to know is this distance, and after we find that distance in bold, all right, we need to subtract it from 50, subtract 50 from it to figure out how farther it had to go. All right, so let's start the problem. I'm going to redraw. So we're going, there's 34 degrees here. All right. And then back down, and this is 20 degrees. All right. So, shouldn't be that bad of a problem here. But what we are given, if we're looking at the triangle room, it's not a right triangle, so no SOHCAHTOA stuff. All right. We are given an angle, side angle. All right, now you're given 2 angles. All right, if you're ever given 2 angles, you can always find the third angle. All right, that third angle is going to be what? All right, 180 minus 34 minus the 20. All right, and so that is, all right, 180 minus 34 minus 20. All right, that's 126 degrees. All right, and that's that angle right there. All right, so let's throw that in there, 126. All right, now from here, all right, remember we're trying to find, all right, for the sake of doing this problem, we're going to just label this ABC. So we're looking for small c and small a. All right. Now, in this case, we have all the angles. Anytime you have all the angles, you can definitely use law of sines. So let's use law of sines. All right. We know 126, and we know its opposite side. So we're going to say sine 126 degrees over 50. All right, is equal to, if I'm looking for C, I'm going to use angle 20. So I'm going to say sine 20 degrees over C. All right, we labeled C for this case. All right, and then, well, let's do that. All right, we cross multiply. We get C sine 126. 126 is equal to 50 sine 20 degrees. All right, divide both sides by sine 126. All right, and that gives us C is equal to all this. All right, we'll punch in a calculator. All right, parentheses 50 sine 20 degrees. There's my numerator. I always put my numerator in parentheses in its own set of parentheses. Sine 126. All right, and enter. And it tells us that C is equal to 21.138. All right, we have to do the same thing again with different All right, to find A, we're going to go sine 126 over 50 is equal to, opposite of side A is 34, is the angle 34. So we got sine 34 degrees over A. Excuse me. All right, cross. So if we cross, we get A sine 126 is equal to 50 sine 34. All right, divide both sides by sine 126. All right, and that'll give us all of this. Let's type that in. All right, and that lets us know that A is 34.560. Now, that means that distance here. So when you think about it, instead of going 50 miles, they went 21 miles, 21 point something, and 34 point something. 0.560. All right, and so what we want to do is add this up first. All right, 34.560 plus 21.138. All right, so the total distance that the plane flew was, if we add these two up, it flew 55.698 miles. All right, and it should have flown 50 miles. All right, so that means that it flew an extra 5.698 miles. And that's what they want. All right, determine the area of the triangle ABC if side A is 4, side B is 10, and angle C is 30 degrees. All right. I look on the formula sheet because I know we haven't had a chance to do any of the area of a triangle yet. And it sets it up really nicely for us. All right. You would be pretty nice if you have a area of a triangle problem, especially if it's this one, because you got a side A, side B, an angle C. All right, so let's write that area 1/2 B sine C. All right, we could draw the triangle if you want. So here we go. All right, say that's C, and that's 30. Make that A and B, and so this is 4. All right, and B is 10. All right, and sort of like a side angle side. All right, or it is a side angle side, but we're finding the area, and we just want to plug the formula in. So we say that the area is 1/2 4 times 10 sine 30 degrees. All right, and well, you could punch it in the calculator if you want, or you can go to your trusty unit circle and know that sine 30 is equal to, all right, 1/2. 3 over root 3 over 2 1/2. So it's 1/2. All right, knowing that, this is 1/2 times 4 times 10 times 1/2. All right, and half of this is 2. All right, that's 20, and half of 20 is 10. So if you wanted to type that all in a calculator, you still get 10. All right, it's up to you. All right, however you want to do the computation. All right, the next problem, similar, we're going to find the area, all right, but we're also going to use law of cosines. All right, so let's jump right into that. All right, a real estate appraiser wishes to find the value of the lot below. All right, determine the length of the third side of the lot. All right, find the area of the lot. Your answer should be correct at 3 decimal places. All right, and it says, and then we'll deal with C later. All right, so we need to find the third side of the lot. That's what we're looking for. All right, take a second to reproduce this graph. The triangle, sorry. All right, 250, 62 degrees, 160. All right, first things first, find the third length of the lot. All right, and in this problem, we are we're dealing with a side angle side. All right, and side angle side, we're going to use law of cosines. All right, if we look at our law of cosines formula, they're giving you angle C, or you're using angle C. So we're just going to make this C. All right, for our case, doesn't matter what A and B, angle A is and angle B is. All right, that means we're looking for side C. All right, let's just call this A. Let's call this B, and then we're using the formula in the formula that's in. All right, now, hope we're okay so far. All right, so the formula for law of cosine says small c, or the side c square, is equal to a square plus b square minus 2ab cosine angle c. All right, and so we have all of this, all right, ready for us. All right, so let's just plug into it. All right, we're going to say that c squared is equal to 250, and these numbers can get kind of big on us. All right, 250 squared plus 160 squared minus 2 times 250, 160 cosine 62. Just fit on the paper. All right. So, a lot of stuff there. We're going to end up taking the square root of all of that, all right, in order to find C. So let's just say C is equal to the square root of all of that. And I'm just going to write it all back out again, because I am going to, at this point, just punch it in the calculator. All right, instead of evaluating step by step, but you got to be careful when you do that. All right, but you can use your calculator. So let's do that. All right, so we say the square root of 250 square plus 160 square minus 2 times 250 times 160 cosine 62, close, and close the whole thing. I want to make sure I'm in degrees. I'm in degrees. All right, hit enter. All right, and it tells us that this side, or C, is equal to 224.816. All right, and for this particular problem, that is feet. All right, so punching that in got us that answer. All right, next question is find the area of the lot. All right. So finding the area, we're going to use that formula again. All right, we know angle C, we know side A, side B. All right, so we're going to say that that area is equal to 1/2 AB sine C. All right, and so our area for our problem is 1/2 times 250 times 160 sine 62 degrees. All right, and let's punch in. All right, I'm going to say 0.5 instead of 1/2. Same thing, right? All right, 0.5 times 250 times 160 sine 62. Close. Enter. All right, so what we're saying is that area is 17,658.952 square feet square. All right, so that's the area. All right, let's put a little box around our answers. All right, so now that I know the area, all right, it says an acre. All right, an acre is 43,560 square feet. If the land is valued at $56,000 per acre, all right, what is the value of the lot? All right, so the first thing we want to do is figure out how much of an acre do we have here. So we can go 17,658.952, all right, divided by the 43,560, or 43,000, yeah, 560. All right, so we're going to take that value and we're going to divide it by an acre. Ooh, so 17,658.952 divided by 43,560. All right, and that's going to give us how much of an acre we have. We have 0.405 of an acre. All right. All right, some more decimal points there, obviously. All right, so if an acre is, if the land is valued at $56,000 per acre, we want to take that value and multiply it by $56,000. All right, so times 56,000. All right, and that tells us that the land is worth $22,702.05 is what I get. All right, and you can check that answer. I'm pretty sure that's right. All right, number 57. It says find the area of the quadrilateral below. All right, so I look at this and I'm like, well, I'm not sure exactly what to do at first, but then when you look at it, we can make this into two triangles. All right, so what we're saying is that we're going to take this and we are going to draw straight across. And if we draw straight across, all right, we have two triangles there. All right, I don't know if you can. All right, this is how you're going to treat this problem when you see it too. All right, just right across. And now what you have is side, angle, side, triangle. All right, and then you have, again, 72 degrees, a side angle, side. All right, and so we can again use area is equal to 1/2 AB sine C. All right, the area is equal to that. All right, I keep writing A, and I probably should have been writing area so you don't get it mixed up with an angle. All right, so every time I did that, I'm sorry. All right, area is equal to 1/2 AB sine C. We use this when we have side angle side. All right, and that's what we have. So we're going to find the area of them separately, and then we're going to add them together. All right, so let's do that. All right, the area of the first triangle is going to be, let's call it area 1, is 1/2 35 38 sine 126 degrees. All right, and so let's find that. We'll cover this triangle for a second. I'm going to go clear. I'm going to go 0.5 times 35 times 38 sine 126. I'm in degrees, so I'm good. All right, that's going to give me 537.996. Doesn't tell us the units, but it would be units square. All right, some units square. All right, and then we're going to find the second triangle. All right, the area of the second triangle. So area 2, all right, is going to be 1/2 50 58 sine 72 degrees. All right, and let's get that again. 0.5 times 50 times 58 sine 72. All right, that's going to give us 1,379.032. All right, and then, well, we know the area of the two pieces. All right, and so we want to add those two areas up, and then we're done. All right, so we're going to go 537.996 plus 1,379.032. All right, 537.996 plus 1,379.032. All right, and that's going to give us the total area, and the total area for this problem is 1,917.028. All right, and I don't know if they want units square, but there you go. All right, and that's it. All right, problem number 27. It says determine the exact value of the following. All right, and I figured this was a good time to go through the unit circle. All right, since we're pulling, if you look at all the denominators, it's over 2, over 4, over 3, over 6. All right, so these are all values from your unit circle. So let's take some time and go through our unit circle. All right, hopefully you can do this before you start the test. All right, and if you're okay with your unit circle, then fast forward through this part of the video. All right, so let's go. All right, first thing that we write is that our ordered pairs are cosine, comma sine. All right, and we're going to do this inside out, so we're going to look at our degrees first. All right, going 0 degrees here. All right, and so when we're doing degrees, we say, when we're doing our degree values to get all the way around, and that helps us to get to 0, from 0 to 360, we say 30 plus 15 plus 15 plus 30. All right, so if we go around our unit circle and do that, all right, 0 plus we go 30 plus 15 plus 15 plus 30 plus 30 plus 15 plus 15 plus 30 plus 30 plus 15 plus 15 plus 30 plus 30 plus 15 plus 15 and plus 30. All right, so we have our degrees. All right, our radians. All right, we're starting at 0. If we go all the way around, we know we go from 0 to 2 pi. All right, I usually take half of that, which is at pi, 180. All right, half of pi would be pi over 2. All right, half of pi over 2, half of 90, 45. So half of that would be pi over 4. All right, and then you see your denominators are 2 and 4 here. This one is 3, pi over 3. All right, and that helps us to get pi over 3 and pi over 6 straight. All right, so this is pi over 6. All right, now the rest of, so that's that first quadrant. All right, the rest, well, first thing we want to look at, all right, is we just want to make sure that we put this information in these other quadrants. All right, so we've taken care of quadrant 1 for our radians. Let's look at quadrant 2, 3, and 4. Wow. All right. The 30-degree angles from the x-axis are all going to have a pi over 6. So this has a pi over 6. This is going to have a pi over 6. Pi over 6. And this one's going to have a pi over 6. All right. All the 45s are going to have pi over 4. And all the 60s away from the x-axis are going to have pi over 3. All right, now from there, we just want to make sure we get the rest of our numerators right. All right, and what we say in the second quadrant, we are 1 short, all right, of 1. All right, in the third quadrant, we say we are 1 more than 1. And this is just one way I know there are several ways to memorize this. All right, and in the fourth quadrant, we say that we are 1 short of 2. All right, so what do we mean by that? Well, in this quadrant where we're 1 short of 1 whole, all right, we can write 1 whole. All right, if this was 1 whole, if our fraction was 1 whole, it would be 3/3, but instead it is 2/3. All right, that's what we mean by that. This would be 4/4, but instead it is 3/4. All right, this would be 6/6, but instead it is 5/6. All right, so that's 1 short of 1 whole, how we memorize that. All right, this quadrant, 1 more than 1. All right, so it would be 6/6, but it is 7/6. All right, here is 1 more than the denominator, 5/6, 5/4. All right, and 1 more is 4/3. All right, over here we're 1 short of 2 wholes. All right, so 2 wholes would be 6/3, but this is 5/3. This would be 8/4, but it is 7/4. This would be 12/6, but it's 11/6. All right, now this value at 270 can take the form of either one of those if we are looking at our 90. All right, so it would be pi over 2, but then it could be 1 more, which would be 3/2, or 1 short of, which would also be 3/2. All right, and so we have all our radians. Now, going back and looking at our ordered pairs, we can do some of them together. Then we'll finish the cosines and then go back and do the sines. All right. So let's do 0 degrees. All right, it's a unit circle, so we're 1 unit to the right, which would be at 1, 0. All right, 1 unit up would be at 0, 1. All right, 1 unit to the left would be -1, 0. 1 unit down from the origin would be 0, -1. All right. Now, in this quadrant, we're looking at our cosine values first. That's why we write cosine comma sine first. All right, and before we start any of these values, we're just going to write over 2 in all of them. All right, now if we write over 2 in all of them, I'll just shorten our time a little bit. All right, so in the first quadrant, everything is positive. All right, and we say our cosine values are going to be like the clock on the wall. We're going 1, 2, 3, but we're doing it with a square root. All right, and we go opposite up. 1, 2, square root of 3. All right, so we take care of everything in the first quadrant. All right, and then basically we want to match up the other quadrants with the first quadrant. All right, making sure our signs are correct. So if we're in the second quadrant, we're going negative, positive. So everything, all the cosines are going to be negative in this quadrant, and we're just going to follow our ordered pairs here. All right, so this one's 1/2 root 3 over 2. This one's negative 1/2 root 3 over 2. All right, this one's root 2 and root 2, so it's root 2 and root 2. All right, and this one is root 3 and 1. All right, we follow that same rule. We can kind of look at our denominators of our radians, all right, to match them up. Everything in the third quadrant is negative, negative. All right, so we can put the negative signs. All right, and we're just going to follow. The denominator is 6, so we go to this one, we write what's here. All right, root 3 and 1. All right, over 4, root 2 and root 2. All right, and here, this is the 1 and the root 3. All right, and we do the same thing for the fourth quadrant. Positive, negative. All right, and we're just going to follow our 3. So the pi over 3 and the 5 pi over 3 get the same values, but we're going to be positive, negative. So all of your signs are negative in this quadrant. All right, so this is a 1 and a root 2. This is a root 2 and a root 2. All right, and this is a root 3 and a 1. All right, and so we finished the unit circle for sine and cosine. Now, I know some classes do tangent and some don't. We've done tangent, and so we're going to add tangent to this. If you want to look at this, if you haven't seen it before, it'd be a good idea. All right, now, because tangent is, and we know this now, sine over cosine, all right, or we can say opposite over adjacent, all right, we can look at our ordered pairs to figure out what our tangents are. All right, so for instance, we take second numerator over first numerator. So our tangent values we're going to write outside the ordered pair are 1 over root 3, all right, which is actually root 3 over 3. All right, either one is acceptable. All right, root 2 over root 2, all right, which is just equal to 1. This one is root 3. All right, now, if you have that, then you can just follow and make sure you're in the proper signs. So here, it's a positive over a negative. So all these answers for tangent are going to be negative. So we'll go negative root 3, negative 1, all right, and negative 1 over root 3, or negative root 3 over 3. All right, same thing for this quadrant. Everything tangent is positive in the third quadrant. So let's go again, positive 1 over root 3, positive 1, and root 3. And here they're negative, so negative root 3, 1, and negative 1 over root 3. All right, and that's the whole unit circle. All right, so if you have the unit circle, all right, and you know your unit circle, all right, I can close my eyes, I see a unit circle. I know that's kind of weird, but if I need it, it's there, all right? Or we can figure out the values without doing a unit circle altogether. My suggestion to you is that you do a unit circle, all right? All right, so now that I have the unit circle, we can get back to problem number 27. Welcome to those who skip forward, all right? So A is sine sine pi over 6. All right, sine pi over 6. So I go to pi over 6. I look at the second value. That's 1/2. All right, cosine. Let me use this whole thing. I don't need that calculator. All right, sine pi over 6 is 1/2. All right, cosine 5 pi over 4. All right, we can go to 5 pi over 4 right there. First value, cosine is first value, so it's negative root 2 over 2. All right, tangent. Well, it's a good thing we wrote our tangent on there. All right, not everyone does tangent. Have you memorized tangent? But we do. All right, or at least we try. All right, 5 pi over 3. All right, so 5 pi over 3 is here. It is negative root 3. All right, sine 3 pi over 2, all right, which is at 270, 3 pi over 2 and 270, all right, and so we take sine, which is second value, which is negative 1. Whoop, whoop, negative 1. All right, E, cosine pi, all right, cosine pi is negative 1. Tangent pi over 2. Oh my gosh, you know what? We forgot something on our unit circle. We'll do it right now. All right, on our unit circle, we forgot about this 0, 90, 180, and 270 for tangent. All right, so remember, tangent's always sine over cosine. So this is 0 over 1, which means the tangent is 0 here. All right, tangent is 1 over 0 here, which is undefined. All right, here it is 0 over negative 1, which is 0. And here it is negative 1 over 0, which is also undefined. So, sorry about that. All right, now we got it. Okay, so for tangent pi over 2, it is undefined. All right, keep it going. What am I looking at? All right, tangent, all right, negative 7 pi over 2, or 7 pi over 4, excuse me. All right, so instead of going all the way in this direction, 315 degrees, all right, we go in the negative direction, which is clockwise, 315 degrees. And so what that's equal to is 45, or pi over 4. So this is also equal to tangent pi over 4, all right, which is equal to tangent is equal to 1. All right, h, all right, h cosine negative 4 pi over 3. Again, we're going in the negative direction, which is the clockwise direction, actually. All right. Now let's find 4 pi over 3. If you're not sure, you would go 240 degrees in this direction. That would be 4 pi over 3. But in this case, we're going 240 degrees in the negative direction, clockwise direction, and that would pull us at 120 or 2 pi over 3. So this is also equal to 2 pi over 3. All right, and in that case, that for cosine is equal to -1/2. All right. I know this is getting kind of junky. All right, we'll keep going. All right, sine -11 pi over 6. All right, again, 11 pi over 6 would be 330 degrees. All right, but we're going in the negative direction starting at 0, and that will pull us to pi over 6. All right, so that's equal to sine pi over 6. All right, and sine pi over 6 is equal to 1/2. All right, then we get some easier ones. All right, sine pi over 4. All right, sine pi over 4 or sine 45 is equal to √2 over 2. All right, excuse me, cosine 5 pi over 6. All right, 5 pi over 6, all right, is at 150, or cosine 150 is negative √3 over 2. All right, you notice this is a no calculator problem. All right, no calculator at all. All right, tangent 7 pi over 6. All right, we know it's going to be positive because it's in that third quadrant. All right, and that's 1 over √3. All right, keep it going. Secant. Secant. Well, this is what I do when I'm doing this problem. I don't try to figure out what secant is right away. I know that the reciprocal of secant is cosine. All right, so I'm trying to find cosine 5 pi over 4 first. All right, and then I'm just going to flip that answer. All right, that's the best way. Well, that's how I like to do it. I know other people will explain it a different way. All right, so I'm going to go to, well, first of all, it's negative, so we got to work this backwards, right? So 5 pi over 4 would be at 225. All right, but we got -5 pi over 4, so we got to go 225 degrees this way. All right, so this is the same as 3 pi over 4. All right, and cosine 3 pi over 4, all right, is equal to a negative √2 over 2. All right, a negative √2 over 2, which means that secant is the flip of this, the reciprocal of that. So this is -2 over √2, and I don't think you have to rationalize that. If you do have to rationalize that, then we can go √2, √2. All right, and what happens is that this is just -√2. All right, so I know you don't like those, but we got a couple more. Cotangent 5 pi over 6. All right, at least it's not negative this time. All right, so I'm not going to try to find this because I don't have that value on my unit circle. All right, I'm going to try to find tangent, and then I'm going to flip it. All right, so tangent 5 pi over 6. Well, tangent 5 pi over 6 is a negative 1 over √3. All right, and that just means that cotangent is going to be negative √3 over 1, which is just a negative √3. All right. All right, let's finish this up. All right, we have cosecant 4 pi over 3. All right, and so I'm not going to try to find cosecant. I'm going to find sine. All right, of 4 pi over 3 first. All right, if I find that, 4 pi over 3 is here. Second value is a negative root 3 over 2. All right, which means cosecant is going to be the flip of that, negative 2 over root 3. All right, I can go root 3 and root 3. All right, if we have to. I think that might be acceptable. I'm not sure. All right, that would be the proper answer. All right, and then the last but not least, secant pi. Well, once again, I'm not trying to find secant pi. I'm trying to find cosine pi. All right, and cosine pi is equal to -1. And if I flip -1, I get -1. All right, and so those are your answers for all those problems. All right, if you're looking for problem number 29, it was done on the previous section, so you can take a look there. All right.